Hello, we are team number 5 of Petronas Twin Tower. Last week, we talked about the sky bridge of Petronas Twin Tower, but we thought that we didn't fully dealt with issues about sky bridge. So today, we are going to look after whole story, structural issue, and the construction of the sky bridge. First, let's look into the whole story about the sky bridge. Let's think first about what sky bridge is. First, there should be two buildings, and second, these two buildings are connected. This is the basic concept of sky bridge. But since we are architecture engineering students, let's put ourselves in the builder's shoes. The Petronas Twin Towers have a height of 177 meters, length of 58 meters, width of 6 meters, and weight of 800 tons. A typical Asian elephant weighs 4 tons, therefore it can be thought that 200 Asian elephants are located about 180 meters above the building. Then, how did they pull such a heavy structure up to 180 meters? If a structure falls during the pull-up process, this can lead to a major accident. Japan's Hasama Construction Company, which actually has experience in skybridge construction, abandoned its bid for skybridge because it was so dangerous and sophisticated. In this context, Samsung and Kukdong Construction proudly won the skybridge bid, which successfully completed construction without a single accident during the construction process. Then, let's look at why skybridge construction is so difficult and how Samsung and Kukdong Construction solved it. First, the building is located at a very high altitude of 180 meters tall. Winds have the property of increasing speed with height, and when buildings are located in such high places, these strong winds cause vibration, exhaustion, and cracks in the building, affecting safety. Construction was immediately suspended if the wind in the tunnel between the buildings hit more than 10 meters per second, and later, when it calmed down, it was a cumbersome task to start construction again. Second, we found a wind tunnel test result by CFD analysis on Petronas Twin Tower. And from the study, we figured out that wind speed on skybridge level is 1.5 kilopascal, so it was designed to resist up to 35 meters per second. Third, they used tuned mass damper in the skybridge leg. Tuned mass damper in each sloping skybridge leg reduce leg vibration, mitigating movements, and avoiding metal fatigue. Last, regardless of how the two individual towers may independently move or twist, the skybridge stays firmly in place by a complex system of hinges, expansion joints, and spherical bearings. The problem was raising 325 tons of central area, which could be lifted in 20 hours with 8 high-strength cable jacks. But the salvage was carried out for 3 days due to 2 lightning strikes that burned the control. It is a matter of lifting structures close to 800 tons to high positions. To distribute the weight, the skybridge was divided into the main center and several assembled parts. Skybridge, which is unmistakable highlight of Twin Tower, was tested and planned for a year through a 9-step process to finish at once without incident, and salvaged for 2 weeks. The final issue was about the collapse of Samsung Department Store. The collapse of Samsung Department Store occurred on June 29, 1995, while assembling the steel frame of Skybridge. This led to the stereotype that a 5 to 6-story building could not be built properly. Supervisors in Malaysia and the United Kingdom have been disgraced for being monitored around the clock. Then, let's look into the structure of Skybridge. Skybridge is basically the connection that enables the movement of two twin towers. In choosing structures, several factors were considered due to the height of the building and its complex movements in its absence. Components consist largely of main girder, skybridge leg, and support. Rotational pins exist in the center of the main bridge girder, just above the center of the arched structure. This is to enable natural movement of the center point up and down when there is horizontal movement of the two towers. The central pin and sliding pad are the factors that enable the movement of the skybridge. The flexion of the main bridge girder enables vertical movement of the skybridge. Expansion joints at the center minimize flexural deformation of the girder. Let's look at the process of creating a structural form of the bridge. Various options were studied in the early stages and then proceeded as follows. The bridge support was designed in the early design phase to support the upper part with cables and the lower part with instrument-like support for thread play. The design, reminiscent of a spider's web, is stable because it hangs legs with iron wires, but it has a disadvantage that the building can be cut off by shaking. An arch support was then chosen. As you can see in the picture on the right, it has been transformed into what we know. The bridge's support lifted a 1.1 meter diameter steel pipe obliquely from the bottom of each tower, eventually allowing both supports to meet at the bottom of the bridge. The tilt of the bridge can be minimized due to the movement of both towers due to the support being centered. The four completed 1.1 diameter steel pipes begin with support points on the 29th floor, climb at angle of 63 degrees, and meet at two flat main girder on the 31st floor. The response of long slender cylindrical bridge legs to vortex shedding excitation at low wind speeds was of particular interest. Member behavior was studied with the dynamic properties of the legs. Mode 1 was pairs of legs moving in a position. Mode 7 was 4 legs moving the same way. And the Mode 9 was each leg in a pair moving in a position. Excitation to the level of destructive resonance was not a significant concern. It was a problem about the millions of cycles of vibration, not the wind speed. Vibration can accumulate, which causes fatigue, a progressive growth, a common, normally beginning of steel cracks. In conclusion, differential movements between closer elements, Mode 1, require more force, and thus yield shorter periods of movement between more separated elements, Mode 9. So Mode 9 was chosen. The structure that evenly distributes the cutting behavior of the two towers. When the two towers move in reverse or twist, the spring point of the arch through the spherical bearing does twist. At this point, if arch support collapse, the bridge itself does not collapse but only deforms on the spot. Each of the 4 bridges has an effectively separate structure from skybridge and tower. 2 hinge arch structures supporting the leg have rotational pins or spherical bearings at the end of the supporting leg. As each tower moves horizontally, the spherical bearing rotates at the spring point and the supporting leg bends at the top. Now, let's look into the brief construction process. First, install a jack-up system to lift the skybridge structure approximately 50 stories above the 2 towers. Next, pull up the lower leg of the skybridge one by one up to 29-story high, then fix it to the spherical bearing using a control cable. Next, construct the central part of the skybridge on the ground while the lower part of the skybridge legs were installed. After, raise the center part to 11 meters above the ground using the jack-up system and install the upper part of the bridge 10 meters long. The central part of the skybridge, which was dismantled and transported by 493 components from Korea, can be divided into 3 main parts. The first is the end block. The end block is the part that connects the skybridge and the 2 towers, measuring 8.3 meters long and 30 tons. The second part is 2 leg supports. Each leg support is 42.6 meters long and 60 tons each. The last is a central part, 41 meters long, more than 5 meters wide, and 9 meters high. A total of 307 components were assembled, and the basic finished material was subsequently taken. Using the jack-up system, the finished center part is raised a little higher than 41 story. Afterwards, temporarily connect the lower and upper parts of the leg and fix it in position after the stress test. Construction of the skybridge was completed by laying concrete on the floor of the skybridge and dismantling the jack-up system. This is it for our presentation today, and thank you for listening.